Welcome back, Scarlett. Let's continue trying to answer the question, why does it hail? In the first week, you observed that during a hailstorm, some of the water gets cold enough to freeze. When we analyzed weather data, though, we saw that hailstorms happen on days when the temperature is above freezing, which is really weird because hail is made of ice. When you analyzed data, you also saw that hailstorms tend to happen later in the day in the spring, summer, and fall, which again is really weird. Hail is made of ice. You would think it happened in the winter. So that made us wonder, what is the temperature like higher in the sky during a hailstorm? If it's hotter down here, maybe it's colder up here. So last week, you looked at weather balloon data and you observed that as you move higher up, the temperature decreases or gets colder. Regardless of the season, winter, summer, spring, or fall, the air gets colder as you move up away from the ground and into the atmosphere. This may have surprised you, as you may have known that heat rises, and you might have predicted that the air closer to the sun would be warmer. But the weather balloon data showed us that temperature decreases as you move up. You may have noticed this if you've ever been on an airplane and the window feels cold or gets icy. This is why you can see snow on the tops of mountains, even in the middle of the summer, when it's warm at lower elevations. When you hike far enough off the mountain, you can feel the difference as you move up. It does get colder the higher you go. The weather balloon data also showed us that the air temperature at very high altitudes, approximately 40,000 feet, is coldest in the winter. Finally, something that made sense. Today you're going to combine what we learned from the weather balloon data, the temperature high in the sky, with the weather tower data, the temperature nearer to the ground, and create a model that shows how the air molecules are moving. Let's talk about today's assignment so you can get started making your models. If you're on a phone, make sure to use print layout. And if you're on a computer, make sure to fit your document to your screen. Today we'll summarize what you learned in 6th grade about kinetic energy in molecules, and we'll create a model that shows how air molecules move near the ground and higher in the sky. First, you'll complete a 5-minute ed puzzle. Then, you'll match the vocabulary words to the picture and fill in the blanks. After that, you'll choose how you're going to make your model. You can make it paper pencil and take a picture, or you can make your model using Google Drawings. If you're making your model on paper, it might help you to start by drawing this. If you get stuck, watch this video for help and then put the picture of your model here. If you're making your model with Google Drawings, you'll go to the next page and you'll double click on this picture to make your model. When you're done, press save and close. The last thing you'll do today is make a prediction. What do you think would happen if we collected temperature data very near the ground, like we put the thermometer on the ground? Or what do you think would happen if we looked at weather balloon data taken at noon instead of midnight? Remember, all of our weather balloon data was from midnight when the sun wasn't out. Share your prediction on Padlet and include your first name in your prediction. Please don't include your last name to be safe online, but we want to know who's predicting what. Finally, rate yourself from 1 to 4 on how well you understand the targets, and stop. You've completed Tuesday's work. Don't turn it in yet. You'll come back on Thursday to complete the assignment.